We will be learning a little bit of number theory in this video. In particular, we will talk about remainders of squares. We will learn this using a problem from ISI entrance 2012. This is objective problem number 2. Here is the question. There is an equation x square plus y square equals 2007. We want to find out the number of integer solutions of this particular equation. What does that mean? We want to find out integer values of x and y that satisfies this equation. How do we go about it? So we will be using a strategy known as remainders of squares. So let me tell you what the strategy is. If you take any number x and if you divide that by 4, there are 4 possible types of remainders that you can get. 0, 1, 2, 3. So any number x can be written as 4 times some quotient plus 0. This is the divisor, this is the quotient and the remainder. This is general form. Or you could write it as 4 times some quotient plus 1, or 4 times some quotient plus 2, or 4 times some quotient plus 3. Any number x can be written in one of these 4 forms. Now we were interested to find out what happens if we square such a number. Let me make some space. If we square this first number, first type of numbers, then we'll get 16q1 square, which when divided by 4 produces remainder 0. So remember that any number divided by 4 gives remainder 0, 1, 2 or 3. We want to now find out what happens if we divide square numbers by 4. So the first type gives remainder 0. Now the second type, you can do a little bit of calculation. Let me do it here. 4q2 plus 1 whole square. This is 16q2 square plus 8q2 plus 1. So if you divide this quantity by 4, the remainder is 1. So 4q2 plus 1 whole square when divided by 4 gives remainder 1. Now you can check what happens in the other two cases. 4q3 plus 2 whole square, if you divide that by 4, the remainder will again be 0. And 4q4 plus 3 whole square divided by 4 gives remainder 1. So something very interesting happens here, that if you divide a square number by 4, the remainder becomes either 0 or 1. So that's the result that we are going to use. So I'll write the result here. You can do this with 7 and other numbers. You can change the divisor and check what happens to square numbers. So if you divide any square number by 4, the remainder is 0 if the number is even, or 1 if the number is odd. So if the number is even, its square will give you 0 as remainder. If the number is odd, the square will give you 1 as the remainder. This is the result that we are going to use to solve this problem. How do we do that? Well, let's go to a new page. So x square plus y square is 2007. Now notice that both of these numbers cannot be even, because then their sum would have been even, but that's 2007. Similarly, both of them cannot be odd, because then their sum would be again even, which is not the case. So exactly one of them is even, other one is odd. Now if you divide, suppose x square is even and y square is odd. We can assume that without loss of generality. So if x square is even, that will produce remainder 0 when divided by 4. If y square is odd, then it would produce remainder 1 when divided by 4. So now we see that x square plus y square would give you remainder 0 plus 1, that is 1. The left hand side, whatever the value of x and y is, it would give you remainder 1. So 0 plus 1, this 0 and this 1 added up. And now we are almost at the very end of the problem. The left hand side gives remainder 1 when divided by 4. What happens in the right hand side? What remainder does 2007 produce when divided by 4? Remember, if the remainders do not match on the left hand side and the right hand side, then we can say that there is no solution. So can you write the last line of the solution in the comment? Tell me how many solutions are there of this particular equation. By the way, we could have used modular arithmetic in this particular problem. I did not use that because I wanted to keep things simple. But using modular arithmetic, the argument would have been shorter. This type of equation is also known as diophantine equation. There is a very beautiful part of mathematics or number theory involving diophantine equations. So I will put some resources related to that in the description. You can check that. Keep on doing great mathematics. I will see you in the next one.